My name is Sabrina Bowling. I'm a 7th grade science teacher at Halls Middle School. The lesson and activity that goes with this video can be found from week 5 activity packet that can be picked up at any meal distribution site between 10 and 12 p.m. If you have trouble understanding this video, you may turn on closed captions if available. You can adjust the playback speed to slow down the video. You can consider watching short clips, then pause, listen, and watch again. You can ask someone in your home to watch the video with you. Stop frequently and talk to your partner about what you heard and understood. Today's lesson is on classifying mixtures. Classifying matter as either a mixture or a pure substance. And so this is a review for you. This is classifying matter. And our essential question is, what observations do we make to identify different types of mixtures? And you will know that you understand fully when you're able to correctly distinguish between homogeneous and heterogeneous mixtures. How can matter be classified? We know that an atom is a building block of matter, and elements are made of only one kind of atom, and a compound is made of different kinds of atoms that are chemically combined. So any substance that is made of an element or compounds is a pure substance. Elements or compounds only is a pure substance. A mixture contains a variety of elements and compounds that are not chemically combined. Some vocabulary for understanding mixtures is: a pure substance is a substance with definite physical and chemical properties, such as elements and compounds. A mixture is a combination of two or more substances that are combined physically but not chemically. A homogeneous mixture has the same composition throughout and looks uniform. And a heterogeneous mixture contains particles of different shapes and sizes and has visible differences. What is not a mixture? An atom. Atoms are made, these atoms that make up copper tubing are all the same, so they are not a mixture, they are a pure substance. Water molecules are made of two different types of atoms that are joined together chemically, so pure water is not a mixture. How to tell the difference in the two mixtures? Prefixes can help you understand. The prefix homo indicates sameness or uniform. So a homogeneous mixture has the same uniform appearance throughout. Many homogeneous mixtures are commonly referred to as solutions. So in the bottom picture you see coffee, creamer, and sugar are added to coffee, which makes a solution, and that becomes a homogeneous mixture. The prefix hetero indicates different. So a heterogeneous mixture consists of visibly different substances or phases. In the bottom picture you can see water and sand mixture, and you can see the visible differences. And then you can see a taco. If you take a taco apart, you can see the separate ingredients from each other. Homogeneous mixtures around you may be sugar and water, sugar water. That would be a homogeneous mixture, and of course if you added tea to that, that would still be a homogeneous mixture. Steel, these tire rims are an example of steel. Steel is made from alloys, which means other elements are melted together. Kool-Aid, hairspray, tomato soup are all homogeneous mixtures. Heterogeneous mixtures around you would be things like pizza, a chocolate chip cookie, mixed nuts. You can visibly see the differences. And then some things can look uniform from a distance, like sand, but up close you can see distinct differences. The same is true for soil. Soil has distinct differences. Some things may start out homogeneous, but then become a heterogeneous mixture. For example, vanilla ice cream. If you added chocolate chips to the ice cream, that would become heterogeneous. And then milk is a homogeneous mixture. If you added cereal, that would become a heterogeneous mixture. So today we're going to look at various things from around my home and classify them as either homogeneous mixture or a heterogeneous mixture. So one way that you can tell these two names apart is the prefix homo means uniform or same, and the prefix hetero means different. And that can help you through this review. So one of the things I want to start with is, what is not a mixture? An example of something that is not a mixture would be an element. So anything from the periodic table would not be a mixture. Also compounds, which are made up of molecules. Those are not mixtures. For example, water. Pure water, like from a water bottle, is a pure substance. So it is only made of water molecules. That is it. So let's look at some various things from my kitchen. So I've taken tomato soup and I've poured it out. So do you think that this is a homogeneous mixture or a heterogeneous mixture? If you said homogeneous mixture, you are correct. So let's stick a label on there. And then I have a can of veg oil. So veg oil is made up of vegetables. So if we pour some out, you can visibly see that there are differences in this bowl. And that this mixture has peas and potatoes and carrots and corn. So this is definitely heterogeneous. And so these are very, very good examples of both kinds of mixtures. Another example would be some granola. So if I poured granola into a plate, do you think that that is homogeneous or heterogeneous? If you said heterogeneous, you are correct. You can see the cranberries and the oats and the raisins in the granola. So let's take potting soil. In potting soil, you can see the little white specks. So those little white specks that you can see are visible differences in the soil. And so we would say that this is heterogeneous because it's different. What about hairspray? I wouldn't recommend spraying this inside the house, but if you can borrow your mom's hairspray and go outside and spray it, you're going to see that it all looks the same. So if it's the same, it would be homogeneous. And of course, we can look at the ingredients and see that it's made up of many different things, but it all looks the same when it comes out of the can. What about a little halo? What do you think this is? Homogeneous or heterogeneous? So if we open it, we can see that it's made of different things inside. And so this would definitely be heterogeneous, a heterogeneous mixture. So we can label that heterogeneous. What about mustard? So if we open it up and pour it out, so mustard is made of several different ingredients. But if we pour it out and look at it, it all looks the exact same. And if we tasted any part of it, it's going to taste the exact same. So those are all characteristics of a homogeneous mixture. What about Gatorade? It all looks the same. It's made up of several different things. If we tasted any part of it, it's going to be the same. That's right, a homogeneous mixture. Now let's set some of this aside and let's look at milk. So milk, if we pour some in a bowl, it looks the same, it tastes the same throughout. This would be a homogeneous mixture. But what if we took some Cheerios? Cheerios are also a homogeneous mixture. They all look the same, they're the same throughout. But what if we poured some Cheerios into our milk? What kind of mixture do we have now? We have a heterogeneous mixture. Now, here's a hard one. What about the stainless steel cooking pot? With the exception of the handle, the pot looks the same. No matter where you look at it, the color's the same. Is this a homogeneous mixture or a heterogeneous mixture? If you said homogeneous, you're correct. Now, stainless steel is what this pot is made of. So stainless steel is made up of different kinds of things like iron and carbon and various other elements. And so since it's made up of different elements, we would call this a mixture. And because it looks the same, it's a homogeneous mixture. Well, thank you for your time today. I hope that you have enjoyed this, and I hope that you have a better understanding of how to tell the difference between homogeneous and heterogeneous mixtures. There's an activity page that goes with this of an at-home lab that you can do, and then look for some things around your home that fall into the categories of heterogeneous and homogeneous mixtures.